Let's do section 10.5, page 528, exercise 41, which reads, find A, the interval of convergence of the series, and then for what values of x does the series converge B absolutely and C conditionally? Well, we're going to start by looking at absolute convergence, which means that we want to rewrite this series as the summation from n equals 1 to infinity of the absolute value of x to the n over, and I'm just going to make this n to the 3 halves times 3 to the n. But really, because we know that n goes from 1 to infinity, n to the 3 halves and 3 to the n are both going to be positive for all values. So the only thing we really need to worry about taking the absolute value of is going to be x. So we're going to end up with the summation from n equals 1 to infinity of the absolute value of x to the n divided by n to the 3 halves times 3 to the n. And now we're going to apply the ratio test. And the ratio test tells us that we take the limit as n goes to infinity of the n plus 1 order term divided by the n order term. And then if this is less than 1, then we know that our series is going to converge. So let's substitute these terms in here, and we're going to have the absolute value of x to the n plus 1 divided by n plus 1 to the 3 halves times 3 to the n plus 1. And we are going to divide that whole thing by the absolute value of x to the n divided by n to the 3 halves times 3 to the n. Now, as is almost always the case when we deal with the ratio test, we're going to have many things that we're going to be able to cancel. We're going to be able to cancel factors of the absolute value of x to the n from here and here. And we're going to be able to cancel 3 to the n from here and here. And what we're going to be left with is the limit as n goes to infinity. And of course, we should have had that limit as n goes to infinity for that term as well. And we're going to be left with the absolute value of x over 3 times n to the 3 halves, because we know that the denominator of a denominator is a numerator, divided by n plus 1 to the 3 halves. Now, because absolute value of x over 3 is not a function of n, I can take that outside the limit. So then I'll have the absolute value of x over 3 times the limit as n goes to infinity of n to the 3 halves divided by n plus 1 to the 3 halves. And if I use n behavior modeling, both the numerator here and the denominator are going to go as n to the 3 halves, which means that they're going to cancel, and this whole limit here is going to go to 1. So I'm going to end up with the absolute value of x divided by 3. And this will converge, as we know from the ratio test, if this value is less than 1. Now we know from theorem 5 that when we're talking about a series converging, we have to write it in the form x minus a is less than r, where r is going to be the radius of convergence. And here we're going to have a equals 0. And when we cross multiply on this part, we're going to have the absolute value of x is less than 3. So we know that this series converges absolutely for the absolute value of x less than 3. But what about the endpoints? What about when the absolute value of x is equal to 3? Well, let's substitute the absolute value of x equals 3 into our original series, which is the summation from n equals 1 to infinity of the absolute value of x to the n divided by n to the 3 halves times 3 to the n. And when we substitute in it's still going to be the summation from n equals 1 to infinity, but now it's going to be 3 to the n divided by n to the 3 halves times 3 to the n. And these 3 to the n's are going to cancel, leaving us with the summation of n equals 1 to infinity of 1 over n to the 3 halves. And as we should know now after going through this whole section, this is a p-series with p equal to 3 halves. And we know that as long as p is greater than 1, the series is going to converge. So let's sum up what our answers to the questions are going to be. So for part A, we're going to say that the interval of convergence will be -3 to 3. And yes, I do want square brackets because this series converges at the endpoints, 3 and -3, as well as the interval in between. For part B, we know that it's going to converge absolutely on the interval from -3 to 3. Those are the x values that will allow this series to converge absolutely. And there is no conditional convergence.